So today, we're looking at a very important property of triangles that'll be worth remembering. And we can demonstrate this property with this diagram here. If you look, we've taken the three angles in a triangle and we've put them together to demonstrate that they make up a straight line. And if we remember from before, we discussed the measurement of the angle measure on a straight line is 180 degrees. So what this property demonstrates is that the sum of the measures of the angles in a triangle, so the sum of the angles in a triangle has to add up to 180 degrees. So we can use that knowledge to solve problems like this one. So if I look, I want to find x and y, and if I want to use that knowledge that all the angles add up to 180, I need to know 2 out of the 3 angles, which I do for x. Okay? So if I want to know what x is, I have to know what I already have in the triangle. So if I put 78 and 32 together, I see that that angle measure is 110 degrees. So x has to be 180 minus 110, or the difference between 110 and 180. X has to be 70 degrees in order for that triangle's angles to add up to 180. Now, in order to find y, I have to remember a different property that we just discussed, was that those two angles, y and 78, since they make up a straight line, they have to add up to 180. So if I already have 78 degrees, y must be the difference between 180 and 78, or 102 degrees in this case. So, utilizing the knowledge that straight angles and angles in a triangle add to 180, I can solve for my unknown angles. The problems are similar here, you just have to remember different properties that we've already discussed. So finding x is still the same thing, in that first I take away what I already have from 180 to find out what the difference is. So if I subtract 57 and 59, or what I already have, from 180, I find that x is 64 degrees. And in order to find y, I need to know 2 out of the 3 angle measures, and I only know 1. So what's the other angle measure that I'm going to take away? Well, if I look at the relationship between these angles, these are vertical angles. And vertical angles have the same measurement. So I do, in fact, know 2 out of the 3 angles in my problem. And that gives me y is 74 degrees. So, utilizing knowledge of what angles are equal and that triangles add to 180, we can find our missing measurement. So another property that we're going to talk about is if I have one exterior angle on the shared side, that its angle measure is equal to the sum of the 2 interior angles remaining. Which, if we remember, straight lines have to add up to 180. And since angles or triangles have to add up to 180, and this angle here is shared between the 2 inside and the 1 outside, it makes sense that the sum of the outside has to be equal to the other 2 because they add up to 180 together. So, using that knowledge here, I know that this exterior angle has to be the sum of the 2 interior angles. So x is simply 54 plus 57, which is 111 degrees. Which I could have also found out if I didn't know that property. I could have first found out what the interior angle measure was from doing 180 minus 54 and 57, and found that interior angle was 69 degrees. and then finding x by taking 180 and subtracting 69 degrees. And you'd still get 111 degrees. But knowing that property did make this problem a little bit simpler. So here we can use this knowledge similarly to solve this problem, except my values given to me are different. So here I know that 104 degrees has to be the sum of the two inside. And so if I want to find x, I'm simply subtracting 49 from 104, and I get my x is 55 degrees. Again, I could have solved that differently by first doing 180 minus 104 to first find that this angle is 76, and then doing 180 minus 76 and 49 to see that that is also 55. So either way, as long as you remember the straight line adds up to 180 and the interior of an angles, and the interior sum of triangles is 180, you'll be able to solve those problems. And here, if you're given triangles upon triangles, you have to solve them one triangle at a time. And this problem also needs to know some additional information that I didn't copy down. We need to be aware that this line and this line, call them N and P, we are given that those two lines are parallel, which is very important in this problem because I have this line that connects those two parallels, which creates corresponding angles with 1 and 55 and 75. And that tells me, since 75 is equal to angle 1 plus 55, angle 1 has to be 20 degrees. Now, if angle 1 is 20 degrees, I can also find angle 2 using those parallel lines. So now looking at this line that connects the two parallels, I have a pair of alternate interior angles. So that tells me angle 2 is 55 degrees. Now I can find angle 5 because it is 1 missing out of 3 angles. So the measure of angle 5 I can find by doing 180, take away 45 and 55, and get the measure of angle 5 is 80. Now I also need to know the measurement of angle 4, and I'm also going to find the measurement of angle 3 because we found the other one, so why not it as well? Now, you have to look closely to pick out triangles here, and then use some knowledge of lines to find out missing angles. So, if I want to find out angle 4, I need to know angle 3, which I'm not sure yet. I can find out angle 4 a different way, though, if I knew what the other angle that made up the line with it was. And I could find out that angle if I knew the other 2 angles in the triangle. So looking at this triangle here, I know that the inside angle here is 100 because it lies on a line with angle 5. And if this angle is 100 and angle 1 is 20, this corner must have a measurement of 60 because it has to add up to 180. And if that angle is 60, because angle 4 makes up 180 with it, angle 4 has to be 120 degrees. I can also finish this problem with finding angle 3, because now I know that angle 4 is 120 and the other angle is 45. So 180 minus 120 and 45 leaves me that angle 3 is 15 degrees.